Okay, so here's our skydiver. She has the source, so her velocity is going to be Vs. She's producing the sound. Now, here's her friend on the ground. In this case, her friend is observing her. So she's got velocity of the observer, and the friend observes a frequency of 2,150 hertz, and the source produces a frequency of 1,800 hertz. And we'll assume that the velocity of sound in air is 343 meters per second. And what we have to do is work out the velocity of the skydiver, Vs. That's the terminal velocity. Okay, so part A, we have F dash is equal to V plus V naught over V minus Vs F. This is the standard equation where we're assuming that the source and the observer are approaching each other. In this case, the source is approaching the observer. This observer is actually stationary, so this is 0. Okay, so we've got F dash, the observed frequency is 2,150. That is equal to 343 over 343 minus Vs times 1,800. Okay, now this is very easy to solve. There's just one unknown, so just a bit of algebra. So we can write 1.19444 by just dividing this by this is equal to 343 over 343 minus Vs, and multiplying up, putting this on this side, dividing this by this, and subtracting off the 343 and taking into account the negative sign, we end up with Vs is equal to 55.8 meters per second. So that's the terminal velocity. Okay, in part B, the observer is now the skydiver. So the skydiver is both the source and the observer. So she's travelling at 55.8 meters per second towards the ground, and the sound is being reflected. So the total path length that the sound is travelling is actually decreasing. So in this case, it's like both the observer and the source are moving towards each other. So substituting in, we've got F dash is equal to V plus V naught, they're moving towards each other, so that's 343 plus 55.8 over 343 minus 55.8, so as the source is moving towards the observer. Okay, and then we times that by the original frequency, which is the 1,800. Solving that on the calculator, you end up with 2,500 hertz.